using the hydraulic bench. To turn the unit on, you just have to hit the black button. If you turn it off, you'll hit the red button. To change the flow rate going through the unit, you will move this valve here. The tank has the ability to measure volumetric flow rate. In order to do that, you're going to utilize this lever system. This diagram helps to explain what is in the inside of the tank. So this side we have our masses, which we're going to place on this end here. Now inside the tank, that set of masses is connected to a weighing tank. Water from the experiment is going to drain through the top of the unit, and that water begins to fill up this bucket with water. So the way the unit works is this is on a balance here, and we have a 3-to-1 ratio in the moment arms. And so as the tank begins to fill up with more and more water, then it's going to get heavier, and this is going to go up and hit the stop. Here you can hear it draining out as it's in the full up position. When it is down, the tank will not be allowed to empty, and you would slide the stopper over so it doesn't drain.
So let's take a look at this more in depth by jumping over to PowerPoint, and I'm going to redraw the system. Now the one thing that they don't show in that diagram is that the weighing tank actually has a hole in the bottom of it. And so it's attached to the weights on the outside of the unit. And remember, there's a ratio of 3-to-1. Okay. And so when the left side and the right side are in equilibrium, that top bar is going to be horizontal. Okay. Now, what we're going to do is we're going to first find this equilibrium point, and that's when the weight on the left and the weight on the right are the same. Okay. Then what we're going to do is we're going to add weights to this right side, and what that's going to do is want to move this all the way down, right? And that would lift the bucket. Now, the hole in the bottom of the bucket gets plugged by a plug which is attached to the floor. Okay, so again, as you can see, if the weights are really heavy and the right side goes down, the bucket goes up and it plugs the hole. So when the hole is plugged, we're going to be continually collecting water as water is falling from the experiment and filling up the bucket. Eventually, what's going to happen is the bucket is going to become so heavy that this would want to drop. Okay? And so at that point, eventually this would get so heavy that the water would again be able to drain out the bottom as the bucket has fallen. So let's jump to this next slide here, and we'll talk about the steps that we're going to take in order to collect the volumetric flow rate. So what you're going to do first is you're going to take the weight side and you're going to lift it all the way up. So this is this picture here. This is step one. And what that's going to do is drain the bucket of all the water. So you let go, and now the weight side is very heavy and it drops all the way down. Then you're going to come down to here and you're going to move that metal slider over. You're going to move the metal slide over. Okay. Now, the bucket, if the unit is on, is going to be filling up with water. And so eventually there's going to be some small amount of water which is going to put the system back in equilibrium, and this bar is going to rise and it's going to eventually hit the slide. Okay? Now this slide blocks the bar from going all the way up and therefore blocks the bucket from draining. Okay? Now, once the bar rises and touches the metal bar, you want to start a timer. Okay? Then what you're going to do is add additional weights to this masses side. Right, let me jump back to here. What you're going to do is on the side of underneath the main wind tunnel, you'll see a bunch of large 2 kilogram weights, and you're going to add 3 more on top of the white weight. So in total, you're going to add 6 kilograms. Okay, so that's going to get really, really heavy again. Okay, this thing is going to drop, but sorry, imagine that the slider is still over in the blocking position. Okay, now you've added the 6 kilograms. That side's really, really heavy. Water is going to continually fill the bucket. All right. Eventually, there's going to be enough water in here. Specifically, there's going to be 18 kilograms, which comes from the 3 to 1 ratio on the fulcrum times the 6 kilograms. Okay, so there's going to be 18 kilograms of water, which is going to put this system back in balance. Okay, and when that happens, this is again going to come up and it's going to hit the stop, and it's going to look exactly like this again. Right, so when it hits the stop again, you are then going to stop your timer, and then what you have known is you would have collected the time it takes to collect 18 kilograms of water, right? And from that, you can get the mass flow rate, because the mass flow rate is the amount of mass, which is this case 18 kilograms, divided by the time in seconds. So we'll just see T in seconds, right? And so to get the flow rate, we just have to remember that the flow rate is the mass flow rate, or the volumetric flow rate, I should say. The volumetric flow rate is just the mass flow rate divided by the density of the fluid. And so you'd then be able to give you the volumetric flow rate Q. So what you're tasked to do is use this to calibrate a flow meter, which is on the bench. This is a paddle wheel type flow meter. Okay? The issue with it is known to be inaccurate. Right? So there's a little added task we have, which is calibrating this unit, which is going to allow us to use it, collect good data from it, even though we know it is off. Right? And the way we do that is we're always going to relate what we see on the gauge here to what we actually measured from the process that we just described. Okay. So what I want you to do is do the flow rate calculation by timing the water collection, and you're going to do that about 8 to 10 times in between a flow rate range of about 2 to 11 or so based on this gauge. Right? So first you're going to place it at 2. You're going to do the system of collecting the water and figuring out the true flow rate, and then you can plot that point. What it says on the gauge you put on the x-axis, what you actually get from collecting the water on the y-axis, and you do that a bunch of times for increasing flow rates. And what you're going to be able to do is find a linear regression, okay, that's going to then allow you to use the gauge while you're collecting data. For example, if you then during an experiment measure like 5.5 gallons per minute on the gauge here, you would then be able to come up to your calibration curve, this blue line, read across, and then you would see that's about 3.2 or 3.3 meters cubed per second, and that it was times 10 to the minus fourth in those units. Okay, so it allows me to use this gauge, which is much easier and quicker to do during the experiment, now that I have a calibration curve. So it'll get me the true value of the flow rate, which is on the y-axis.